Let's see what our temperatures and our pressures were on these systems outside in the lab. Some of the basic data we're going to be collecting is our outside air temperature, our indoor dry bulb, and our indoor wet bulb. What's the difference between my dry bulb and my wet bulb? All right, latent versus sensible. How much humidity is in the air? It doesn't play a factor on the outdoor unit because all I'm doing is getting rid of sensible heat. But it does play a role on my indoor evaporator because as it's absorbing heat, it's also absorbing humidity as well, dehumidifying the room. So I need to know my total heat load on the evaporator before I can know whether my system's working properly. All right, let's look at some pressures. Edward, what did you and Brian have on your high side pressure?
285 PSI.
So 285 PSI. What was my saturation temperature in my condenser at that pressure?
92.3.
All right. So I was saturating at 92.3. What was my line temperature?
83.8.
All right, that stands for liquid line temperature. So if I was saturating at 92.3, my liquid line was 83.8. How much subcooling did I have?
2.3.
No, not 2.3. What's 92.3 minus 83.8? So 92.3.
6.
Do what?
4.6.
No, 92.3 minus 83.8.
8.5.
8.5, right? So I had 8.5 degrees subcooling. What would y'all get on your low side pressure?
135.
Which means I'm saturating at what temperature?
46.8 degrees.
And what was your suction line temp?
47.
So what was your superheat then? How much warmer was your suction line than your saturation temperature? That's right, which is almost nothing, right? Because our gauges probably aren't that accurate. So really we have 0 degrees superheat. Let's go ahead and fill in the rest of my information. What was the outdoor ambient temperature around that coil?
76.
All right, about 75 or 76. We'll just say it was 75. Since they were located in the same room, that was also my indoor dry bulb temperature was 75. Josiah was the only one who had to check his wet bulb because his has a piston metering device, not a TXV. What'd you get on it?
61.
61, okay? So me looking at this system, when I look at superheat, it tells me whether my evaporator has the right amount of refrigerant, too much, or too little refrigerant in it. So with a superheat of 0.2, that tells me I'm completely flooded inside of my evaporator. I have too much refrigerant going in. What about my subcooling of 8.5? Does that look okay, or? It's okay. It's a little bit low, but it's okay. What about my condenser split? So my condenser split is how much warmer is my condenser than the air around it. If my condenser was saturating at 92.3, In a 75-degree room, what was my condenser split? So how much warmer was my condenser than the air around it? 85, 95 would have been 20, right? So I'm at about, which I got 17, 17.7. Is that right? Is it 17.7? I'm sorry, 17.3. All right, so what I'm really doing is I'm saying I'm 75 degrees outside, right? How warm was my condenser? Well, I was saturating at 92 degrees. Remember, that condenser's got to be warmer to get rid of that heat, right? So how much warmer was my condenser than the air? So I just subtract my bigger number, my smaller number from my bigger number, and come up with 17.3 degrees. That's not a terrible number, right? That's pretty close to 20. But the number that is terrible is 0 degrees of superheat. So this one's a little tricky. If it were me, I would think I need to go in there and look at my Sensen bulb on there. It may not be insulated, or it may not even be attached. So it may be sensing a lot of air temperature, letting that evaporator operate wide open, instead of sensing that cold line and trying to shut off and restrict it some more. Does that make sense?
Will that make it ice up too?
It wouldn't make it ice up because I'm saturating at 46 degrees, almost 47 degrees. So I'm not going to freeze anything at 47 degrees. What's actually happened, if that sensing bulb on that TXV senses that line temperature correctly and is insulated, if it sees that low of a superheat, should it open up to let more refrigerant in, or should it close to restrict the amount of refrigerant? It should close, right? As it closes, we'll get less refrigerant in that coil. So my superheat should start going up, correct? But what's going to happen to my pressure in there too if there's less refrigerant? It may go down, right? So that pressure may come down closer to 40, and my superheat may go up to wherever that TXV tries to maintain it. Then I'd be operating a little more where I would expect for it to be operating at. Does that make sense? So when we go back out there, before we can adjust our charge, we're going to need to check that. We're going to need to make sure that that bulb is on there and is insulated, because it may not be. That may be one of those pieces of equipment that we took the cover off, and we might have had it out looking at it earlier. I can't remember. But that's something we definitely want to check on that one. So just looking at all these numbers, I can't say that it's undercharged right now. If anything, it looks like I'm either overcharged. I could have a dirty evaporator coil. I could have low airflow going across it. Typically, you would see that number be lower if I had low airflow, a dirty coil, because I wouldn't be picking up heat. So even though I will be flooded and have very little superheat, if any, 0 degree superheat coming out, normally I wouldn't even be able to pick up enough heat to boil my refrigerant off to get my pressure that high, to have that high of a saturation temperature. It would be, yeah, if it was clogged up, or if it had a low airflow, like a dirty filter or something, then yeah, that pressure would just get lower and lower and lower until I did freeze when that pressure dropped. So I know there's a couple of you that never even had the superheat and subcooling from basic refrigeration, so I'm throwing a lot at you. But what happens as this liquid refrigerant goes inside of this coil, all right, it's making its way through there, and it's making its way back, and eventually at some point all that liquid is going to boil off into a vapor. As long as I have both liquid and vapor, as long as I have liquid turning into a vapor, I'm going to stay at that saturation temperature. It's like my boiling water. If I continue to add heat to my water, once it starts boiling, it doesn't get above 212 degrees, right? Until I've boiled it all into a vapor. Once it becomes a vapor and I continue to add heat to it, now its temperature starts going up again. Now I'll have a 213 degree steam, 214, 250, 300, whatever. Does that make sense? But the whole time it's changing its state from a liquid to a vapor, it's not changing temperature. It's using all that energy to go from a liquid to a vapor. So this same thing happens with my refrigerant. At a certain pressure, once it stabilizes, it'll start at a low pressure and start boiling off. And as it boils off, it's going to increase pressure some in here, right? That's why we got to let it run for a good 10 or 15 minutes for it to stabilize, for it to get to that point where it's bringing in new liquid and it's boiling off the existing liquid into a point of pressure that's consistent. Once we know that pressure, we know the temperature that it's saturating at. We know its boiling point. So the whole time at 135 psi, as we're going through here, we're staying 46.8 degrees. Our liquid is turning to a vapor, and that's staying at 46.8 degrees, right? Eventually, all that liquid will boil off. Our pressure is still the same through that whole evaporator, but now that liquid refrigerant that was going through here, let's say we were liquid boiling off, and maybe by here, we're all vapor. Now I'm still blowing my air across it, right? I'm still moving heat from the space I'm conditioning across that coil. So once I get to here, I still have heat hitting that vapor, but now it's going to start changing its temperature some because it's all turned into a vapor. Does that make sense? You with me, Brian? Darielle, are you able to follow? I know it's all kind of new to you guys. So once I get here, my temperature starts changing. That's what I'm picking up right here. When I check my line temperature, my suction line temperature, I should be much warmer than whatever my saturation was. I should have warmed up a good 8 to 12 degrees. So if I was saturating at 46, I would want to be at least 56 to 58 when I come out of there, or at least, something, 54 something. I would want to know that all my liquid boiled off into a vapor, and it's coming out as all vapor. If I have 0 degrees superheat, that means that I'm coming out as both liquid and vapor still. Does that make sense? The only way I know that it's all vapor is if I have some superheat. In this case, I don't. 0.2 is not significant because I don't know how accurate my pressure reading was, and I don't know how accurate my temperature reading was. So I can't say that I actually legitimately have anything above saturation. But if I had 12 degrees above it, then I'd know that I was all vapor coming out. Does that make sense? Similar with subcooling, only that's when we're cooling it off. We're coming in as a hot vapor on a high pressure side, and we're cooling it off. The whole time I'm cooling it off, that's happening at 92.3 degrees. As I'm turning from a vapor back to a liquid, it's going to be at a consistent temperature until I turn it all into a liquid. Once it's all a liquid and I continue to cool it off, its temperature will start dropping again. So I was 92.3 the whole time I was turning into a liquid, but as I checked my line temperature as I was leaving, I was 83.8. Is 83.8 cooler than 92.3? Yeah, 83.8 is 8.5 degrees colder than 92.3, right? So I turned into all liquid and I cooled it an additional 8.5 degrees. So I know that I have all liquid coming out of there because I am subcooled. Does that make sense, Kyle? Good. Colton?
What's the numbers of subcooling and heat like normal range?
All right, so Edward asked, what's the normal range? Subcooling's normal range is going to be somewhere between 8 and 13 is what I usually see it at, usually around 9 to 13, depending on the manufacturer. And superheat, we say, is usually around 8 to 12. So really, they're both kind of about the same. Anywhere from 8 to 12 is pretty standard on either one, superheat or subcooling. All right, he asked how there's not liquid getting into that compressor. I don't know that there's not. There could be, but we have, because it's a heat pump, we have an added component inside of there. Do you remember what it is? An accumulator, that's right. We go through our reversing valve first, right? And between our reversing valve and our compressor is that little accumulator. Compressor, and then the little accumulator. So if we do happen to have some liquid coming back, hopefully it will accumulate in here and all will be pumping back as vapor. The other slight bit of protection, which is not much protection at all, is the fact that this compressor can be hot. So it may flash off. If there's just trace amounts of liquid coming back, it can probably flash off before it actually hits that compressor. But I wouldn't count on that to protect anything. That's just if we're lucky. So when analyzing this system, I can't say whether it's undercharged or overcharged, but I do know that my evaporator's flooding. So that issue has to be addressed first. Once I get it fixed, then I can look at my numbers and see if I'm where I need to be. And remember also, these numbers are only as accurate as your airflow. If your airflow's right, then we can go by our numbers. If our airflow's not right, it's going to throw our numbers off, and we have to make sure that we're where we need to be. Go ahead.
And to get the wet bulb and dry bulb, that's just the temperature of the air coming out, and one has a little white rag on it and one don't.
All right, it's not the air coming out, it's the air going in. It's the temperature of the space. We check that at return because that's the temperature that that coil is seeing. So my dry bulb is just a thermometer reading, just a temperature reading in that house. If it's 75 degrees in that house, that's what my dry bulb is. The wet bulb, you're right, we wet a little cloth of some kind and wrap it around our temperature sensor and we leave it there. Now it's a lot more accurate to buy at least like the little pocket psychrometers that are digital, that are calibrated to pick that stuff up. Because your water, you don't know if your water cold, is your water warmer, is your water distilled, is it going to be an accurate reading, do you have enough air going across it to give a good accurate wet bulb? But I find it's actually pretty accurate, close enough for us to be able to use our charts and things to see if we're adjusted where we need to be. All right, let's do another one. Kyle, let's look at yours. So my low side pressure, what did I have?
45.7.
Low side pressure was 45.7?
Yes.
All right.
This is an R22 system.
So I was about to make that statement. The other most important thing is that we know what kind of system we're working on. All these others that we're going to be talking about are 410A, but this one is R22. So we're going to use a different temperature pressure chart. Hey, Colton, is all our equipment shut off in there? All right. Will you run out there and kill it for me? So an R22 system with 45.7 pressure. I want y'all to tell me what its saturation temperature is. Look on your temperature pressure charts and see if you can figure that out. All right. Josiah says 21.7. 22.3. How about we round it in the middle and we just call it 22 degrees? Instantly, what do I know about that number? I can't be saturating at 22 degrees on an air conditioner, right? What's going to happen to my coil? That's right, it's going to freeze up. So I know that's low. So if I am undercharged, if my evaporator is starving of refrigerant, my superheat will be really high. If I'm clogged up and dirty, or I have low airflow, or my filter's jammed, my superheat's going to be really low because I'm not picking up any heat and boiling off my refrigerant. Does that make sense? All right, so what is my superheat? Well, let me back up. What was my line temperature? 74 degree line temperature. So my superheat is?
I have 51 written down, but it'd be 52 with those numbers. It's probably just one I left it.
So 52 degrees. Is that a lot of superheat? That's what?
More than I've ever seen.
More than you've ever seen? Well, this line temperature is 74 degrees because that's what the room temperature is. So there's not even enough refrigerant in there to really cool that line off much. So is this starved of refrigerant inside this evaporator coil, or is it an airflow or dirty coil issue? I'm starved of refrigerant, right? If I were a dirty coil, I wouldn't be picking up any of this heat. My pressure would be low because I'm not boiling off my refrigerant, but my superheat would be low because it's still liquid coming out. I'm not liquid. The fact that that's 52 degrees tells me that I turned into a vapor way early. I've had such a little amount of refrigerant in there that it was boiling off super early, and then the whole time it's going through there, it's a vapor because it's warmed up 52 degrees past the temperature it was saturating at or boiling at, right? So I know my evaporator is starved now. Let's look at my high side. Without putting any numbers down, what would we expect to see? A high, low, or normal pressure if we're lower refrigerant? Low pressure, we would expect to see, if I have low pressure, I'm going to have a low saturation temperature, right? But what about subcooling? He says high. It's actually going to be a low subcooling. And I'll explain why in just a second. Let's get our numbers. High side pressure was 147 psi. So in R22, what am I saturating at?
81.
At what?
81.
81. What was my outdoor ambient temperature? So my condenser split, or how much warmer am I saturating above the outside air? 6 degrees. Is my condenser very warm? Am I going to get rid of very much heat if I'm not warm? If my condenser is only operating at 81 degrees and I'm blowing 75 degree air across it, I'm not getting rid of much heat that's inside there, am I? Does that make sense? So what about my subcooling? What was my liquid line temperature?
81.
Thank you. My line temperature was 81. So how much did I subcool? 0 degree subcooling. Why did I not subcool any? I've got... All right, but why, when I'm undercharged, why is my subcooling low? So let's think about what's going on in this system. I've got hot gas coming in here out of my compressor, right? I've got to cool that gas off into a liquid, correct? The only way to do that is to get rid of all that heat, right? Heat moves which direction? Hot to cold. How do we make it move faster? A bigger temperature change. Is that a very big temperature change between 81 and 75? So what happens, I'm not getting enough pressure in here to get it hot enough to get rid of all that heat. Does that make sense? So if I could get this hotter, I'd get rid of that heat, and all that vapor would turn into a warm liquid and come out as 100% liquid. But since I have no subcooling, I'm coming out at the same temperature as I'm saturating at. That means I still have vapor and liquid coming out right there. So is this starved or flooded or normal? Starved. So if my low side is starved and my high side is starved, My whole system is what? It's starved, right? So I would very safely say that this is an undercharged system. It has a TXV in it, so when I go to charge it, I'm going to have to, first thing as I start adding refrigerant, I'm going to see this number start to come up, my saturation temperature. And also that number will start to come up. Eventually, this will get somewhere around 40 to 45 degrees, and my TXV is going to start throttling down. And so my superheat's going to start dropping, and when it drops to wherever that TXV wants it to be at, that superheat's going to remain the same. If I keep adding refrigerant, it's going to keep backing up on my high side, right? Because my TXV finally got where it wanted to be, so it's staying there. It's not letting any more refrigerant come in. So as I keep adding refrigerant, where's it going to build up at? It's going to have to be out here, right? It's got to be somewhere. If it can't be in my coil, indoor coil, it's going to have to start building up in my outdoor coil, right? What's the pressure going to start doing then? Rising. I'm going to get hotter and hotter, so my subcooling is going to start going up too. When I have a TXV, I charge it according to my subcooling number. My superheat can be maintained. I may have 12 degrees superheat and only 3 degrees subcooling. I still don't have enough refrigerant in this system. All right, so I'm going to have to keep adding some. This will stay, if it was 12 degrees or wherever that TXV is maintaining, it's going to stay right there. But as I keep dumping refrigerant in, it's going to keep building up out here, causing that pressure to go higher and higher, making it hotter and hotter, which is going to get rid of heat faster and faster. Does that make sense? Until I get to hopefully around 10 degrees or so. 9, 10, 11, 12, somewhere in there is usually where the manufacturer wants it. That's how I know I'm going to be charged, right? Does that make sense? All right. That was R22. Now let's look at Josiah's system. Tell you what, let's save Josiah's for last. What other system did we have? Colton and Darius. What about yours, Brent? Have we looked at yours yet? Okay. All right. Yours was the same as that one. So what do you guys have on your suction side? Low side pressure. All right. This is 410A, right? So we're saturating at what temperature? 38 degrees. Is that high, low, or normal? It's not bad. It's a little bit low, though, right? Little low. Now, if we're in a cool room with low humidity, that means there's not a lot of heat load on that evaporator, so that may not be a bad number. But I still think that looks a little low to me, right? What was my suction line temperature? 71. So how much superheat did I have? How much heat did I pick up past my saturation? About 33 degrees. Is that a lot of superheat? Yeah. So what do I know about my evaporator now? Is it flooded? Is it starved? Or is it normal? Flooded. Flooded would be too much refrigerant in it, right? If I had too much refrigerant, I'd be leaving at the same temperature I'm saturating at. I'm starved because I'm boiling all my refrigerant off too soon, and I'm picking up too much heat by the time I leave. There's too much vapor in there. There shouldn't be that much vapor.
So the higher the number, the more vapor is in it?
Yes, the higher the superheat, the more vapor is in the system. I don't want that much vapor in there. I need to be going from a liquid to a vapor because that's when that big heat transfer takes place, right? All that latent heat, that's when I'm absorbing it. So, superheat is high. That means my evaporator is starved. So let's see, do I have an undercharged system Or do I have some kind of clogged metering device or restriction somewhere? I don't know. Let's look at the high side and see what it looks like. What's my high side pressure? Don't sound bad. 285. So 285 psig. Saturates at what temperature? All right. So I'm at 92 degrees on my liquid line, right? I'm sorry, on my saturation. My space is 75 degrees. What's my condenser split? How much warmer am I? About 17 degrees. Is that good, bad? What do we think? It's a little bit on the low side. It's not terrible. If it's a high efficiency piece of equipment, that wouldn't be bad. Yours actually is a high efficiency piece of equipment, isn't it? I think y'all have a 17 SEER 2-stage ream. So it's really not bad. That's I'm okay with. That's a little low. That tells me that we're starved. What about my liquid line temperature? 91.5. So what was my subcooling? How much did I cool off from my saturation? None, really. So I have no subcooling. So after I looked at everything in this system, what do I decide about it now? Do I think it's overcharged, undercharged, operating properly? There's a restriction. He thinks it's undercharged. Who agrees with him? Everybody does. I agree with him too. So if you're not looking at everything, how would you ever know that? If I walked at this system and I said, well, I'm saturating at 38 degrees, I'm up here and I'm saturating about 92 over here, that looks about right, right? But then when you finish looking at all of your numbers, I'm starved out here and I'm starved in there, right? So I'm definitely going to need to add some refrigerant to try to get that subcooling up. Outdoor air, or outdoor ambient, whichever you want to call it. Remember, ambient just means the air around us. The ambient temperature is just the temperature around that condenser. So that's pretty good. You guys are getting good at this, right? You can go check your system at home now, see if it's undercharged area. Yeah, if you got your EPA card. But you got your EPA card. There's nothing illegal about it. There's nothing to catch. Sorry, I hate to tell you, but if you got your card, you're legal. Nothing you can do about it. You just can't do work for somebody else and get paid for it. Then you have to have a contractor's license. Stefan or Brandon, I think they both do the mechanic. But I can help you out with that if you want to. I can set you up to take that test. What's the next question? Can I buy liquid ammonia? I don't know. I don't need any liquid ammonia. All right, did you have a question? I'm glad you asked that. All right, so now we're going to look at Mr. Josiah's. Josiah's unit is different from all the ones that we checked because Josiah's unit does not have a TXV, which is a thermostatic expansion valve, and it does not have an electronic expansion valve. It has a fixed piston. So its metering device is literally just a small hole. All right? So that's going to be different because as I start adding refrigerant with my TXV system, eventually, I told you it's going to block it off, right? It's only going to allow what needs to come through there. Okay? and then it's going to start backing up in the condenser. However, if I have a fixed metering device, that piston has a tiny bore inside of it, a tiny hole, it's going to allow however much high side pressure is pushing on it. The higher the high side pressure, the more refrigerant is going to be forced into my evaporator coil, right? Okay. When I start checking superheat though, that's going to determine my heat load on that coil and how much pressure I have pushing refrigerant in there. As we're looking at this stuff, it's always a balance between the heat load and the refrigerant. If I have this much refrigerant, I need this much heat to boil it all off, right? If I have too much refrigerant, not enough heat, I'm going to have very low superheat and I'm going to have liquid coming out. If I have very little refrigerant but a lot of heat coming across it, I'm going to boil it all off quickly and I'm going to have really high superheat. Does that make sense? It's throwing a lot at you at one time. But all I'm doing is trying to find that balance between my heat load and the amount of refrigerant to absorb that heat. So as we look at Josiah's system, we'll start with the outdoor ambient temperature. 75 degrees, right? So I use a check and charge chart. It's called a superheat chart. This one is Emerson check and charge. I'm going to tell it we're 410A. And I'm going to say superheat non-TXV. The reason I say that, I told you on a TXV system we're going to charge based off of subcooling, right? Because the TXV's job is to maintain superheat. So I'm going to keep adding refrigerant until my subcooling's where it needs to be. On a fixed metering device, I'm not going to charge based off of subcooling. I'm going to charge based off of superheat. But what my superheat needs to be is going to vary depending on my outdoor ambient temperature and the heat load on that coil. Do you follow that?
You said check charge.
Check and charge. It's Emerson check and charge or Copeland check and charge. I don't remember.
Check mark and it has and charge.
Yes, it does. It's Emerson check and charge HVAC. It's got a check mark and then it says and charge.
And wait or off.
Yes. All right. They're going to ask for this information right here. They want to know the indoor wet bulb. We were at 61. We'll say it was 62 in there. So 62 on my indoor wet bulb, I'll set it. Condenser dry bulb. So now they're just asking for an ambient temperature, right? It was set at 75. They want to know what my vapor pressure was. I just make this up because I don't really need them to tell me whether I need more or less refrigerant. I just need them to tell me what I should be at. But we can go ahead and plug it in. What was your vapor pressure?
107.
107. So I can put that in under vapor pressure. We'll say 108. What was my vapor line temperature?
35.2.
So we'll say 35. Once I calculate that, it says my current superheat is 0 degrees. It says my recommended superheat is 15 degrees.
What was
I haven't put it in yet, but the outdoor ambient temperature was 75.
is this 410?
This is 410A, yes. So according to this, my recommended superheat was 15 degrees, but I have 0 degrees. If I have 0 degrees superheat, is that evaporator starved or flooded? Or normal? 0 degree superheat. Starved? Think about it. 0 degree superheat means that I've got liquid and vapor both coming out. That means I didn't boil off all of my liquid inside of here. So I have too much refrigerant in there, right? Because I didn't even boil it all off. However, at my low side pressure of 107, what is that temperature?
34.
34 degrees. That looks kind of low to me. What do you think is going to happen when I start removing refrigerant? It's going to go down, right? And I'm going to start freezing that coil up. So what was my superheat? 0 degrees?
That means too much refrigerant, or?
Yeah, it means there's too much refrigerant in there. But the other thing I've got to look at now, if I start removing refrigerant, my temperature is going to drop. So maybe it's not a refrigerant issue alone. Maybe that thing has a dirty coil in it and it's not picking up heat. Or maybe my airflow's bad. I don't have enough air going across it. If I don't have enough heat hitting that, I'm not going to be able to evaporate what refrigerant I have in there. I mean, it could be. It's not. It was still blowing good. I'd have to check airflow to see if it's blowing as good as it should be. But if I had a suggestion, it would be probably to clean that coil. It's probably dirty. Do what? No, say it again. You said with it being a piston, should it be a higher superheat? Yeah. Yes, your superheat is going to vary depending on what your head pressure is and what the load is, what the heat load is on that coil. So using my chart, and I have slide rules and different things that all tell me the same thing, what my superheat should be under given conditions. Using that, I should have 15 degree superheat, but I have 0 degrees. That means I'm not picking up enough heat, or I have too much refrigerant in there. If I had too much refrigerant in there, that pressure would probably be a lot higher. So I do have too much refrigerant, but just because I don't have enough heat going across it. Does that make sense? I'm not picking up enough heat to boil off what refrigerant I have in there. So that's why we got to look at all this stuff again, because it may not be just a refrigerant issue. If you don't understand how this stuff works, you see a pressure that low, 34 degrees, what do you think Bubba out there is going to do when he sees that pressure so low? How's he going to get that pressure up? He's going to dump more refrigerant in, right? But what's happening? I'm already flooded. I'm already sending liquid back to my compressor. What's going to happen when Bubba dumps a bunch more refrigerant in on this? We're slugging that compressor now. That's exactly right, and we're going to damage it. Why? Because Bubba don't understand how this system works. Bubba's just used to seeing pressures, and when they ain't there, he either adds refrigerant or he takes it out, right? We don't want to be like Bubba. There's some good Bubbas out there, don't get me wrong. But the one I'm using in my example is a bad Bubba. That's why it's important for us to understand all the dynamics of these systems before we just start dumping refrigerant in. So if it were me looking at this, I would say, because that number's so low, I can't take more refrigerant out. Can I add more heat to it? Well, I'm in a 75 degree room, 61 degree wet bulb, which is a little bit low, so my heat load is already a little bit lower. But I could tell by looking at all my other systems in this same room, they were all operating up closer to 40 degrees, right? So the heat load in the room is not so much the issue, but for some reason, that refrigerant isn't absorbing it all. It's staying a liquid and not picking up all that heat that's being blown across it. Either I need to increase that airspeed, make sure I don't have a dirty filter, or more than likely that coil may be dirty and need to be cleaned because it's not picking up heat. Make sense? So those of you, we've analyzed your system, we know what to do now, right? We're going to add some refrigerant to it, and Josiah's, we're going to check it out just to see if there's something we need to do to it. To add refrigerant, 410A has to be added as a liquid, right? We got to flip that tank upside down. Do we weigh it into the high side or the low side? We have to weigh it into the low side. Why? We can damage our compressor by weighing it into the low side, but I have to weigh it into the low side because the high side pressure is too high. The pressure on that high side is higher than the pressure in that tank of refrigerant, so it won't go into the system. The only way to get it in the system is to suck it in through that low side, right? But we're sucking liquid refrigerant in, so we don't want to slug our compressor, so we slowly throttle it in a little bit at a time. So don't damage my compressors. Slowly throttle it in. Once you've put some in, we wait another 5 or 10 minutes and let the system stabilize, do all our checks again, and see if we need to add more. Normally, if you're way down here at like 20 degrees saturation, it's safe to slowly keep throttling it in until you get up there close to 35 or so, 35 to 40, and then wait your 10 minutes and let it stabilize and see if you need to dial in a little bit more. When I'm that low, I don't have a problem doing about half a pound at a time until I start getting fairly close to where I want to be. Then I'll just slowly throttle it in an ounce or two at a time. Make sense? All right, good deal. Let's go get it.